Hello, grade 8. How are you today? I hope you all are safe and well. Today our lesson about corrosion reaction. We might heard about corrosion, the meaning of corrosion. And can you remember what is corrosion? Corrosion is something that rust or reacted with water. So this is rusting that we are calling the iron, old iron, or like rust iron. This is the corrosion. So we studied about the chemical equation or the word equations for any reactants. So today we will see this reaction as corrosion reaction. This is one of the kinds of the reactions. We studied about combustion reaction, and this is another type of reactions called corrosion reaction. So open your books on page 163 and follow me. Grab your highlighters and follow me. Corrosion reactions. Reactions useful or not. So is this corrosion reaction is useful or not useful? Because here we can see that is old, the car is broken, it's rusty. So is it useful for the metal or not? Many chemical reactions are useful. Chemical reactions make medicines. So this is one of the usage of the chemical reaction. Fertilizers and cement. So we are using also the chemical reaction for making cement and for making cement and making fertilizers. Combustion reaction release energy to cook food and make cars go. Chemical reactions keep living things alive. We all know in our cells or the organisms, living organisms, inside their cells all the time there is a reaction is taking place there. Without this reaction, these cells will not be alive. But some chemical reactions are not useful. Read on to find out more. So look at these three pictures here. You have this car made from steel, which mainly iron, it's covered in rust. Here we have the roof made from copper, here like this, and here in these, and this one, this is made from copper. Its surface is covered in green compound called verdigris. And we have here forks, old forks or rusty forks. These forks are made from silver. Their surface are covered in black silver sulfide, except of one which has been cleaned. So here, these reactions, because of what or why we have these corrosions, we have different kinds of corrosion reactions, and what causes this reaction on these elements. Let's find out more. Rust, verdigris, and silver sulfide are formed in corrosion reactions. A corrosion reaction is a chemical reaction that happens on the surface of a metal. Most corrosion reactions happen slowly over days and weeks rather than seconds or minutes. So it's impossible to see or to find a corrosion reaction that happened in minutes or in seconds or even hours. But this could take days, weeks, or sometimes years. So this corrosion reaction, it's a reaction that happened on the surface of the metals, not deeply in the metals inside them. No, we can find it only on the surface. Sometimes this corrosion could be useful to protect the layer underneath it, and sometimes can destroy the metal completely. And this reaction happened or is happening because of the reaction of the surface of the metal with the air. If the air contains water, so the water and oxygen could join to the metal and form this this layer that we call corrosion. So let's see some metals as iron, and we can identify, how can we identify the corrosion in them and what do we call it? So iron corrosion, or we call it rust, it's a big problem. We can see it as red substance on the surface of any iron products, or sometimes steel, because steel is mainly iron. It happens when iron reacts with oxygen and water. The oxygen comes from the air. The water may come from the air as vapor or be in its liquid state. So if it's something wet, or if it's a piece of iron wet and kept in the air for like days or weeks or even months or years, as under the rain, it will rust, and it will form a layer of rust, which is a corrosion that the iron will react with the air and the oxygen in the air and the water that comes from the rain, and will form a layer, red layer on the surface that's called rust or corrosion. The product of the rusting reaction is hydrated iron oxide. So this could be a good question here. What's the product of rusting reaction? The product of rusting reaction is hydrated iron oxide. Why we said hydrated? Because if it's produced because of the water, and anything related to the water we call it like hydro or hydrated. So hydrated iron oxide because of the oxygen in the air. So this is iron oxide with water joined loosely to it here. Loosely, that it's not like that that strongly. Okay, you can even scratch it with your nails, or you can scratch it with your hands. It will just like come out with small pieces. You can break it easily. The word equation below summarizes the rusting reaction, which is iron plus oxygen plus water. The water here is important to produce hydrated iron oxide, because iron with oxygen, like if we burned iron in the air, it will form a combustion. It will be a combustion reaction, and we will get iron oxide. But with water, we will get a rusting reaction, which is hydrated iron oxide. Rust forms on the surface of iron, not deeply, but it will start in the surface. On the surface, it's soft and crumbly. It easily comes off the surface of the metal. This leaves more iron exposed and ready to rust. So it's not like a strong layer, it's not a tough layer on the surface. So it will be soft, crumbly, you can like break it easily. So when it come off because of winds or by anything like hands or animals or anything, these layers underneath it will be exposed more to the water and the air again. They will be ready to rust even more. Okay, this was about iron corrosion. What about the copper corrosion? Over time, copper reacts with substances from the air, such as carbon dioxide. The reactions make green compounds, for example, copper carbonate. The green compound cover the surface of the copper. They do not easily come off, so the copper underneath is not damaged. So unlike the iron oxide or hydrated iron oxide is we said it's soft and crumbly, but here the green compound or the copper carbonate, the green compound, which is we call the verdigris. This green carbonate, this green compound, sorry, it's not easy to come off, so it will protect the copper underneath it. You can see this in any old copper plates or copper products like rings or plates, forks, anything old. You can see like a green layer. This green layer is poisonous, and it's not easy to scratch it. Even if you try to scratch it with your hand, you cannot remove it. So in this case, the copper underneath this layer is well protected. Okay, so what about the silver? Does it corrode or not? We all know that silver, we are using it to make jewelries. We make very expensive products. So why, or materials? Why it's expensive? Actually, the silver is expensive because it's not easy to corrode. So even if we kept it underwater, or if we kept it exposed to the air and water, it will not corrode. So silver doesn't react with oxygen or water at 20 degrees. 20 degrees is the room temperature, or the natural temperature that we have. In clean air, it doesn't corrode. So this corrosion of silver could be with conditions. So silver does not corrode with oxygen at 20 degrees or in the clean air. So it doesn't corrode, just it has another conditions to corrode. Polluted air may contain hydrogen sulfide. Hydrogen sulfide reacts with silver. The product is a black compound, silver sulfide, which forms on the surface of silver. So with this condition, silver could be corrode with the polluted air, because polluted air may contain hydrogen sulfide. Here, the hydrogen sulfide will react with the silver, and the sulfide will the hydrogen will replace the silver. So it will form silver sulfide, and this silver sulfide will form on the surface of the silver as a black compound. You have to pay attention in this paragraph, because you might have a question in it. So how does the silver corrode? So silver doesn't corrode in clean air or in room temperature at 20 degrees in clean air, but it does corrode at polluted air, because it might contain hydrogen sulfide to react with the silver, and it will form a black compound, which is silver sulfide on the surface of the silver. So after all these types of corrosions, or examples of corrosions, how can we prevent corrosion reactions? Steel is mainly iron. We said that it could corrode, so how can we prevent it? Most of the metal things we use are made from steel. So iron corrosion, rusting, is an example. Is an expensive problem, because it might cost us to lose our product. So because this layer, as we said, it's soft, it can come off, and we can lose all the material, and we can lose all the steel. Oxygen and water make iron rust. We can prevent rusting by keeping oxygen and water away from iron. Chemists do this by coating iron. So we need to coat iron. How can we coat iron? We can paint in cars. We can oil or grease in engines. Grease, which is like something like wax, okay, or like very thick oil. We can use it in engines, and we can use another metal. So we can cover this steel with another metal that could corrode easily. So in this case, it could corrode and prevent corrosion of the steel itself. Ben's bucket is made of steel. It's covered in zinc. Even if Ben scratches the zinc, the iron doesn't rust. The zinc reacts with oxygen instead of iron. So this is Ben's bucket. So it's made of steel, so he covered it with zinc. So in this case, if you remove the zinc will react with the oxygen instead of the iron. It will rust, so the iron will not rust. In this case, he will not lose the bucket. Okay, we talked about the iron corrosion, copper corrosion, silver corrosion. So does all metals corrode or not? So not all metals corrode. Some metals do not corrode in the air. Gold and platinum do not react with substances from the air or water. Gold is very expensive because it's very suitable and it's perfect. It doesn't react. It's still shiny. It will still shine even underwater. And even platinum, which is the white gold, as I mentioned before. And they cannot react with substances from the air or water. Even gold, they discovered, some people discovered gold or treasure of gold under the water that kept for years or lost for years and maybe like thousands of years. So they just found it. It's the same. It didn't corrode. The elements stay shiny for thousands of years. The surface atoms of a piece of tin react quickly with oxygen from the air. The tin is another element, is another metal. It could react quickly with the oxygen, so a thin layer of tin oxide forms on the surface of tin. The tin oxide doesn't react with substances from the air or water. The tin beneath is protected. So here, if the tin atoms react with the oxygen, it will form tin oxide. The tin oxide will not react with the air or the water, so the layers under the tin oxide will be protected. So here the word equation could summarize this. Tin plus oxygen give us tin oxide. Aluminium metal is also covered by a layer of its oxide. The aluminium oxide protects the aluminium underneath. This aluminium cannot take part in reaction. So here we have we call it like silver plates. These are not silver plates. These are aluminium plates. And just we call it silver because of the color. But actually they are aluminium plates. We can use them to preserve foods or a food or liquids sometimes. So why we are using them? Why we are using them safely? Because these are covered with aluminium oxide, so the layers beneath them will not react with the water or the oxygen, even if we kept them in the air. Exposed to the air, or even if we kept them under water, like if we washed them, they will not corrode because the aluminum oxide is covering the aluminium metal underneath it, so it will be protected. So now let's go to see the summary of the lesson. Corrosion reactions. Iron rusts when it reacts with oxygen and water. Rust is hydrated iron oxide. Corrosion reaction. This is a definition for the corrosion reaction. You can use it to define the corrosion reaction. Is a chemical reaction that happens on the surface of a metal when it reacts with substances from the air or water around it. Corrosion reaction happens slowly. This is very important. It doesn't happen in minutes or seconds, but it takes days, months, years to form. So this was all about corrosion reactions. Don't forget to write these notes in your notebooks, please. If you have any question, write it down, and don't forget the yellow box. I hope to see you soon safe, and see you next time in a new lesson. Bye-bye.